Hey everyone, welcome back to JETSON AI Lab. Today is August 20th. Thank you guys for coming out. We have a full house of people here today to present, which is great to see so much new projects and activity. Hannah, our intern from the JETSON team, is going to be presenting the Gen AI nodes for ROS 2 that she made this summer, which is awesome. We were working together to kind of merge the Gen AI stack with ROS, and now that that's gotten much more embodied agents and physical AI, we're getting to the point of doing this on actual robots, which is super great and exciting. I have a couple brief updates to show about Open VLA in the context of that. And then Catalan has been doing a lot of great work on the Isaac ROS side and the sim, integrating that with JETSON and making a bunch of these really nice and easy to follow Medium articles for people getting started with ROS. And it's I even like read and Google those when I get stuck and scratching my head with things. So thank you for all of those that you put out. They've been super helpful. Then Azir has got the Flux model from last week running on JETSON, which is great, and kind of launched us in this whole direction of looking more at the diffusion models and other image generation technologies for use at the edge, which keep coming up. And then if Vedant from Miru is here, they were going to talk about their edge AI infrastructure that they have for JETSON for managing and deploying fleets of IoT devices, which is really nice platform. But first, I believe Lakshankta from Ultralytics wanted to briefly talk about their YOLO World event that's coming up that seemed to be really exciting. If I don't like Shankta, I don't know if you wanted to share for a minute or talk about that before we get rolling.
Yeah, thanks, Dasin. Thanks, Dasin, for giving me the stage here. So I'll just quickly spend a couple of minutes here. Can I share my screen? Okay. Yeah. So can you see my screen?
Yeah. Yes, we can. Thanks.
All right. So I'm Lakshant from Ultralytics. So I joined last week also to talk about like our Ultralytics YOLO documentation on JETSON Gen AI Lab. So today I just want to like spend a few minutes to talk about our event, which is coming up next month, which is our annual YOLO event, which is named as the YOLO Vision, and this is happening for the third time. And so this is pretty much like a hybrid event where like we focus on data and machine learning and computer vision advancements. So different like researchers, engineers, and developers from various industries come to this event to share their ideas and knowledge. And also, like since this is a hybrid event, it's happening. You can either join offline or online, and it is completely free to join this event. So just simply you can click the register now button. So I will copy and paste a link on the video on the chat right here, so that everybody can see and yeah, you can join. And also like you can welcome to sponsor our event as well. And so this event will be mainly happening on the September 27th on Friday at starting from 10 a.m. to 5 p.m. Central European time, and it will be happening in Madrid, Spain, at Google for Startups. And if you are joining online, we will be streaming on YouTube and also streaming on Bilibili for the Chinese audience. So welcome everyone to join the YOLO Vision event, and I hope it will be very exciting. So thank you very much again, Dustin, for giving me the time. Yeah, thank you, Aaron.
Yeah.
Thank you.
Yeah, and it does look like a really nice event, and I did register for this. Azir, you should go if you're not too far off.
It's in my city,
great.
so.
Okay. It's awesome that YOLO is and Ultralytics are able to sustain an event of this scale, and I believe just speaks to like the interest in like practical computer vision and everything that you guys do. It's an awesome community that you've built up. I guess we can, while we're on the topic, we can quickly round out our discussion from last time about using the DLA for
Yeah,
YOLO
yeah.
V8, and you did try that, and it a bunch of
Yeah,
layers
for
didn't
sure.
run on
Yeah,
VLA, and
yeah. From the
that
last meeting, like that was
okay.
some great insights where like we did some experiments where we try to run the export process on the DLA, but it seems that from my initial experiments, some of the layers are not supported to run on the DLA, like when we export to TensorRT engine. So some of the layers fall back to the GPU. So I mean, so right now, like when it comes to the overall inference time, it's a little bit more than what we get it directly from GPU, you know.
Okay.
So
Yeah. And
yeah,
that part
yeah,
is actually normal. Like you should not expect
yeah,
DLA to actually be faster than GPU. It's there for power efficiency and to offload. But
yeah,
yes, it does have a limited layer subset, and there are some detection architectures that do map to it, like DetectNet V2 and SSD and some of the others. But it may or may not be worth it to you to investigate, like tweaking the Onyx or whatnot. It all depends. Probably if you have some large customer that comes and say like, I want to deploy this on Orin NX, which has the DLA, and want to be as efficient as possible. It's one of those trade-off things. But regardless, really appreciate those containers
definitely, yeah.
that you guys put out. And I've been hearing like people have been trying those on the forums. Like this is way easier than before, particularly like the Jetpack 4 users. So thank you so
Right.
much for that, and look forward to continue working together. And I also
Definitely
continue
very excited for that. Yeah.
to hope that you do like a VIT version of YOLO or take that next step into VLMs, which are our experience from the past 4 6 weeks here and training our own versions of those. I think everybody will get more into it over time. Okay, with
For sure.
that,
Thank you. That's
let's
yeah.
thank you, and good luck putting on your event. I know like that's a lot. It's always like so much fun, and meeting everybody in person. I'm sure you have like lots of demos or announcements that you're working on to do all that. Okay,
For sure.
so let's launch into like the ROS 2 discussion that we wanted to start off. And now that I have the Open VLA working. I'll just show it here briefly. I was going to show it a little later after China's thing, but we'll just get that out of the way now. Okay, so I was fortunate to get on 2 A100 nodes over the weekend and got this trained up and working better with domain randomization and different prompts and stuff like that. And the accuracy and picking is improved, and it stacks the blocks most times now. So I'm like able to work with the tutorial. We have the ROS 2 nodes for this to get this into like actual robot. Been looking at doing like the ground rover version of it for just like a basic test building on top of it. There's lots of other enhancements that I can continue to make in here, including like smoothing out the motion, making it faster, doing like a miniature model, probably like the Vila 3B, so we can take this from 3 FPS that it's running right now to more like 7 or 7.5. And what it ended up taking longer in this study, which turned out to be more scientific and in depth than previously had done, because it involved like pre-training and this being a wholly new architecture. Characterizing these things like the loss curves and here's the training results from it over the weekend. So I'd started with training it on 500 episodes of data, just like this, where it's trained on the simulator over time. It dropped. It seems to be doing about like 80-90% accuracy, which is way better than it was last time that I showed this. It was like maybe like 20% then. So I started off training it for 500 episodes, and then the blue one is 1,000, and this green one is 2,500, and basically characterizing how does the amount of fresh data that it was trained on correlate to its actual accuracy and success ratio. And the initial results that we got from this are, this should be 80% and 82%. It does increase over time marginally, but that seems to translate to a much larger increase in the actual success rate of it. So it did take longer than just the initial 100 episodes, like the paper said, to do. Maybe it's because this sim environment is significantly different than what they did in their real world studies. But I'll continue to like collate all the data from this and make a short little tutorial for the JETSON AI lab that you can use to run this, and you can go off from there and fine tune it yourself. And you can still do the LARS on the JETSON. That's fine too. But we also have these like ROS nodes for it as well. So with that, I will turn it over to Kenna, who can talk about this ROS integration that we've been working on over the summer to actually transition this stuff from video analytics side or more experimental side to actually being on robot and getting more field testing in. So Ken, I don't know if you wanted to take over the screen sharing, you're welcome to. Awesome, we can see your screen now.
So yeah, this whole summer I've been working with Dusty to integrate VLMs into ROS2 using his nano LLM container, which is just VLMs and LLMs that are optimized for JETSON. So basically what's on this GitHub is, first I have like a little example of the node running. So this is like me and my friends are just doing different poses. And then on the right is what the model is kind of describing. Like it's just describing what we're doing. And then there's some setup steps here. Also how to get into developer mode so you can create your own stuff. How to run the actual container. And then like the parameters. So it takes a model, which is whatever VLM you want to use. It takes the API and it takes quantization. And then some of like the topics that I use where there's an input image and there's an input query. So you have to give it an image and then something to do, like describe the image or like, is there a box in the image, something like that. And then it spits out a response to your query based on the picture. And yeah, it just publishes the output. And then in addition to this, so all my code is on here. And I created a tutorial on JETSON AI Lab of basically like everything I did so that you can adapt this for like any type of model. And so the first part is just running it. And then this is how I actually built it. So I have like concrete steps here. And yeah, all the code is here. You just need to make little edits. And that's what I've done this whole summer.
Awesome. Yes. And it would seem like the ROS2 node itself wasn't too bad for you to do. It's pretty simple, like text in, or image and text in and text out. But I remember it did take us some effort to get all of those containers like compiled together, and just like the testing of these systems is pretty complex. And thank you for creating that package and setting us all up. In the future, we'll continue to build those lightweight wrappers around various, Gen AI components that we're doing. And anybody can now take that and essentially copy and paste. If you want to do llama.c++ or Gemma 2 or drop in whatever into ROS, that's a very easy template for you to follow. The container that we pushed for that is the biggest one that we've done so far, because it combines all of the LLM and Gen AI stuff with ROS2 Humble, and it was, I think, like 25 gigs or so. So it was quite large. But hopefully this ushers us into the era of doing like onboard local Gen AI in ROS. I've known that folks have started experimenting with LLMs in ROS for some time now, but it was all calling OpenAI essentially, which is cool for researcher folks that are wanting to discover like the art of the possible or whatnot. But our focus has always kind of been on the edge deployment side. Let those foundation pioneer model researchers go off and create those models, and then we'll focus on actually deploying those. So kind of let me ask you, what type of use cases or robotic applications do you think we'll start to see in ROS with like access to this stuff now that we have it?
Yeah, so it's actually really cool is like, and you know about this too. There was another intern and he was a PhD student and he used my node to kind of give robots short-term memory. So what he would do is he would use the node and the robot would go like around a warehouse, let's say, and it would store like all the descriptions of the scene within itself. And then it would be able to like answer questions and take you to different places based off of what it saw. So that's like a really cool application.
Okay, yes, awesome. Yeah, it's almost like using the vector database or whatnot, but on board the robot to go around and collect that knowledge. Because we know LLMs don't have long-term memory per se outside of what's in their context window. So there is some other systems that need to be on top. And I'm sure there'll be a lot of work and experimentation to figure out how these all plug in to the stack. Because like with the embodied open VLA, that's pixels to actions, essentially, it could handle the whole system, or maybe you have a safety layer underneath with like solid state stereo or LiDAR that acts as that additional safety layer with like a YOLO human detector on there running like out of band. But also, you can just drop those things in and basically do like the prompt engineering, which a lot of folks seem to start be like percolating down and making more sense to them, which I totally understand. So when you talk about these alternative pipelines and workflows where the robot is going out and collecting memories for its long-term memory bank that then can get embedded into the LLM context, all those types of things are workflows that had not previously like been done before. And I think there's various levels that you'll see that integrated with. So yes, it could literally just be on top of your existing planner if you're using Move It or Nav2, or it could go all the way down and like drive the whole robot. So it will be very interesting to see if we can make like the JetBot of Gen AI from this, that like anybody can take and quickly collect the memory bank and do some LoRa or fine tune if needed, and go off and just do a very simple embodied agent with that. That's kind of what I would like to look towards next with this like open VLA thing. Now we like finally have one that is working up to the specs of the initial paper. We can now look towards what's next, and I think that includes both the UGVs and like optimizing it for the smaller models. Hopefully the UGV is actually simpler to do, because it's not this 6th degree of freedom robotic arm that is a very challenging problem space to solve. In like your experiences with ROS this summer, was there any other thing that you think we might be missing, or anybody else from the group? Now that we're having this discussion on like our ROS 2 infrastructure, what we need, other runtime components that you guys might find necessary, or other pain points that you have with using ROS on JETSON would be good for us to take a look at and address now that we're continuing to ramp up. And we do have collaborations with the Isaac team. Hannah and I had various projects ongoing where like we make this node and then those go off and get used by these other projects, which is great. Oh, Martin, yeah, you have a question, buddy?
Yeah, so I have a contribution that I tested like all these different ROS middlewares. So I can put a link in the chat. Basically, there's like a Cyclone, FastDBS, Zeno, and also when you have like images, point clouds, and so on, you want to use like zero copy. So there's like a combinatorial explosion of all these different settings. So I made a repo. I can share it with you. It's mainly aimed towards depth cameras and so on. Yeah, and I tested it on JETSON. Yeah.
Awesome. Okay. Yeah, drop a link in there, and I'll dig into it. Jay from Numerous, good to see you.
Hey, Dustin. Yeah, it's been a while since we chatted. Yeah, we've been busy working on our next generation software, and I'm hoping to reach out to you, connect, and get some time on here. But
yeah, you should come and do that. So Jay from Numerous, they have, drop your link in the chat, Jay. They have a nice platform that's like built on top of ROS and has a lot of additional functionality for edge.
It was designed to take away all the low-level drivers, plugging in cameras, lasers, motors, RG pilots, user interfaces, everything you need to actually work on your research or your project that everybody else has to do. And it was just, creating a full-featured environment around ROS. And so anyways, I think, I'm excited. We're with the next release to get that out there. We're trying to get into a lot of universities and things like that, where, people don't need to be a software expert to actually create this. I mean, I think everyone here knows how hard it can be bringing up these systems. So
yes, unfortunately, and like even like I've just been focused on the model part, and finally looping back to the actual physical robotic thing, which is always just such a time sink. You can spend your entire work week.
Well, we spend a lot of money and time bringing this up, but I'm excited to get this in front of everybody. And so anyways, I'll reach out and I'll put the link in there and get some time.
Yeah.
Okay.
I think one of our issues with the ROS stuff and making it more accessible for people is, although it's like very powerful and become essentially like necessary given the complexity of these systems, is the presenting it as examples to folks. It basically is just like a launch file, right? And presenting that to them, how to like dissect that. And it's not just like a simple Python script that you can step through the pipeline with them. It's more like, okay, here's this collection of nodes, and then there's this spaghetti tangled mess of like Catkin build scripts and launch files and
that's exactly what we're trying to get rid of. If you want to get in there and do that, it's all open source. But what we say is, for most of the people, that we want to get this to, if the word Linux comes up, we've already lost them.
Yes, and it always is good to keep in mind that perspective of, because we really do want to broaden our reach of folks that are able to use AI for practical applications in their real life, because that's where things are heading with this. And eventually, like, everybody's gonna have to be robot mechanic or get into this for their own purposes. And no, they're not all going to be Linux experts, but hopefully, like even my kids, my 7-year-olds, they understand the machine learning workflow and how the camera on the JetBot functions to be able to drive it, and the whole data collection and training thing. And like they're able to do that through Jupyter interface, essentially. They're not coding or like no Linux or anything. So that type of mainstream accessibility will be important for folks to remember. And I know like the commercial robotics guys, they all do have like the nice web app interfaces for all of this that are like customer consumer facing, but you gotta like roll up your sleeves too and be able to add new features to your
Yeah,
robot.
but
figure
same
out.
thing, all those interface stuff. I mean, that's, you know, you'll see it, but we provide that. It's all customizable, and the goal is,
Right.
again, those are interfaces that everybody's recreating at every company, you know, that they don't need to start from scratch. But it's,
Yes.
you know, the challenge, not the challenge, but, you know, where a lot of the discussion here is about the next cutting edge. For us, what we try to do is take technologies, you know, from not the past, but bring technologies to the people, essentially, right? You know, make them usable, make them, and not, we're not about the cutting edge. We want our customers to focus on the cutting edge stuff, right? So things like SLAM, you know, I've been in robotics industry for about 20 years, and, you know, SLAM is always, it's been there for a long time, but it's still so much researchy, right?
Yeah, and it's even prevented myself from fully delving into the whole thing, even though I've literally worked on optimizing SLAM for JETSON.
Yeah.
It becomes overwhelming when you talk about the overall integration of the system. So having these more of like drop-in GUIs and things like that, on my end, like making connectors from all of our LLM stuff into ROS should make that easier. And ROS has traditionally gained a lot of traction in like the UGV space. Or manipulators, maybe a little bit less so. Jay, I was wondering, like, do you see interest from folks doing robotic arms in ROS, or like how?
Yeah, I mean, I think there's three main areas. One is manipulation. So, you know, one of our core applications we built the software around was to provide systems like MoveIt the information they need to grab something. So you want to, you know, you want to quickly train, deploy an AI model with a 3D sensor like a stereo labs camera, and fit a model to it and tell the, you know, the MoveIt software where that object is. That, you know, there's a lot of work that goes into that, and we don't do control systems like MoveIt, but we essentially, our motto is bridging the gap between sensing and autonomy, right? And so that's one, but a lot of students that, you know, get a Pixhawk drone and they want to do some AI enabled, you know, automation. Again, we interface at a low level or at a high level with the Pixhawk and the RG Pilot, and quickly they can set up AI and send commands, you know, move here, move there, based on those detections. But it's really, it's a platform. So, you know, we've got companies in the medical space that we're talking to. We've got sonar companies doing 3D AI enabled, you know, net monitoring sonar. We don't care. We just want to make it, you plug in your cameras, your sonar, your lasers, your motors, and you write a script, right? And then interface it with a bigger system. So
yeah, okay. I kind of get that. And like our end, that bigger system or like the AI agent running it would be like one of those LLM pipelines.
Yeah, you could just, you know, again, add a, you know, your own node in there that, you know, interfaces with the rest of the system. So one of the big things that we did was all of our hardware drivers, whether it's a sensor or a motor, they have an abstracted layer. So every camera, laser, sonar you plug in has the same interface to it. So the application layer doesn't care. It doesn't need to know anything about whether it's a USB camera, an OnViv camera, or anything like that.
Yeah.
We auto detect it and provide that interface.
And that's like the promise of ROS, right? Is all this inter-cooperation.
Yeah.
Should you abide by them? With like the devil's in the details. And there's a comment in the chat from Renan, and I totally understand the you know, sometimes you love ROS, but sometimes you hate it when it doesn't work, but you all plug it in. And for better or worse, like we've supported ROS on JETSON community since like the beginning, and have helped people with those builds and containers all the way back to ROS Kinetic with Ubuntu 14.04. So it's always like people use it when it is right for them. There is a lot of folks out there continuing to use it. You don't have to do your whole system in it, but I would guess like most folks doing a actual robot at some point have some tie-in to that.
Yeah, but even a lot of our
like,
customers don't even know the word, what ROS is. I mean, you don't have to, ROS is a tool, right? Ultimately you're trying to create a solution, and the end customer doesn't, they don't need to know what ROS is, right?
Yeah, well, it's more for us, and of course, like
Yeah.
NVIDIA has Isaac ROS and all of these like super optimized nodes in there, and that's like really what we want to be able to leverage without becoming too entangled per se.
Yeah, and this might not be the right platform, but really the idea is that all the developers here on this call and around the world that are developing amazing ROS or whatever technology, how do you monetize it? How do you get it to end users, get it into systems? Because we all know, everything each of us is doing takes a lot of work, and in the end,
Yes.
it's a part of the puzzle, and you need to get it in there. So, anyways, I'll reach out to you.
We'll come back in a couple of weeks and we can dive in again, because this will continue to come up now that we're getting more into like physical AI, and it's all becoming more real. And like, yes, years ago I was more into robotics directly and then focused on vision and all the algorithms, because it was taking a lot of time just to like mess with the physical platforms. And but then since then, simulation tech has come a long way. And with that, Catalan has done a lot of really excellent articles on Medium and GitHub about, getting started with ROS, Isaac Sim, and piecing all of that together. Because even as an NVIDIA employee, it's both amazing and overwhelming the amount of material out there to get into for somebody that's like integrating and pulling all these pieces together. It's a lot to.
Well, it's the amount that's there today, and next week you guys will double it somehow. Is the problem?
Yeah. Well, and then like all the models coming out, it's a lot to keep up with. So, Kevin, I don't know if you wanted to screen share and walk us through some of your. You can start at just like your Medium account level and give us a quick overview of like your entire corpus of training material that you put together, and then the most recent thing that you've done would be great to drill into, in particular the hardware in the loop piece that's like very relevant to what we're doing now. Thanks for joining. I know it's like middle of the night over there. Thank you.
So is my audible? So my screen is visible, right?
Yeah. Yes, we do see your screen. It's just sharing the meeting itself.
So thank you for this wonderful opportunity given by the Dusky. Thank you.
Thank you. Yeah.
So this is my Medium article about hardware and looping, simulating the carton robot in the Isaac Sim, and doing the computation part in the JETSON Orion Nano. So in the Orion Nano, I will dump the Isaac ROS code for the April tag detection. So if the robot is detecting the April tag, it will follow the April tag in the environment. So the Sim2Real is implemented by the technique of.
Can you zoom in a little bit, given the margins on the?
Now it's
there we go. All right, thank you.
Yeah. So the Sim2Real point of view I did with the ROS. So in ROS, we'll follow the DDS network protocol for transferring the data between the different devices. So the device will be my laptop, and the Orion will be connected in the same network and with the same domain ID. So the domain ID we need to fix in the BASIC file. We can give any domain ID, like I give the domain ID 10 in a Orion and also in my laptop. So the data will be transmitted between the laptop Sim to the Orion Nano to the object detection or April tag detection point. So I will show the live demo. You will get an idea about that. So the April tag detection is take place in the Sim, and also if the tag is detected, robot will start moving. You can see. So if I remove or move the tag from the robot perception viewpoint, it will stop. So I'm going to move the April tag from.
Oh, I see it now. Okay. It looks great. Yeah.
So actually, robot will stop the following the April tag detection point. So in ROS, So ROS is a visualization toolkit in ROS. So well, I will launch once again.
Okay, yeah, this is what we're talking about. There's like 18 windows going to like all this stuff working together, and it's great when it works, and then when there's one
So
point in it that's broken.
That is a visualization toolkit. Well, we can visualize the sensors input in the ROS. So well, I launched the simulation part in Isaac Sim. So with the April tag detection. So if the tag is detected, robot will start moving. If it is not, robot will stop. So the April tag detection is take part from the Isaac ROS package. So in my Git repo, I give the Isaac ROS package repository from the NVIDIA. So this is a Isaac ROS repository. We need to clone first. So then I give my own code for April tag detection for following the April tag. So
okay. And that is running on the Nano, the actual like vision.
Yeah. So actually, I do. Yeah.
Awesome.
So actually, I connected the Orion Nano with the SSH with my system, and I launched the Isaac ROS package in my system in Orion. So in Orion, we can find out that. So what are the ROS topic is running on our system, we can visualize by the. So I am running the Docker now. So after running the Docker, we can find out the active topics which is running on our system. So we can find out that tag underscore deduction. So this is a topic of April tag deduction, Isaac ROS April tag deduction topic. So this topic.
These two machines are in the same ROS namespace. Is in the PC has ROS on it, and that's how it interfaces with the ROS on the Nano.
Yeah, Nano place is here.
Okay, that's good to know. It's not as if you need some SIM component on the JETSON to import it. It's just all native ROS.
So this is an Nano one. So
okay.
So we can find out that the topic which is running on our system is tag underscore deduction, right? So the tag underscore deduction is a topic of Isaac ROS deduction topic. This is an active topic. So we need to subscribe this topic with the node which I created in the Git repo. So this is a node. Yeah, I will zoom it. So this is a node which is subscribed with an Isaac ROS topic. Okay, we need to subscribe the topic of a tag underscore deduction with the node here. So the Isaac ROS deduction information will be shared between this. This is a subscriber node, and Isaac ROS April tag deduction is going to be a publisher node. So well, the deduction is take place if the robot is start detecting the April tag, it will start moving to the point. So like the landmark localization process, and the entire computation is take place in the Orion Nano. So Orion Nano is connected with the Ethernet with the same network in a laptop, and Isaac ROS in the same network, Isaac Sim also in the same network. So the data will be shared between Sim to real. So this will take place on the Medium blog also.
Okay.
So
awesome. Yeah, and this is a super helpful skeleton of, because you can drop in whatever for the April tag thing, but just to understand how to like connect all this all, could you quickly walk us through like the launch files that you had to create, or on the Isaac Sim side, what does it look like setting that up and launching it? Were there other assets you needed to create on that end for it?
Yeah. So well, already in Isaac Sim they given the Isaac utilities and Isaac assets. So if you need to launch the Isaac Sim environment or Isaac ROS testing environment, we have the Isaac examples. Here we need to go to the ROS 2 and we need to launch those examples, and we can try our hardware looping testing or any our own algorithm testing in the simulation part of point.
Okay.
So here
and then
we can,
yeah, it just sets up the topics then from there. And okay. Have you dug into much of like custom scenarios or whatnot in Isaac Sim?
Custom scenario, right?
Yes.
Yeah.
Like if you wanted to do some, like let's say I wanted to do like an outdoor one, or have it actually do like a task or something that requires not just preloaded. And I get like you know more about using this than I do, probably because this is requires an RTX GPU in order to run.
Yeah.
But it looks fantastic.
So this is one of our custom robot, ROS Master Xbox robot with a mechanism wheel driver. So
Cool.
actually,
That's like the RP LiDAR. I still have one of those.
yeah, actually we have the hardware also. We are working, me and Ninant from the NVIDIA. We are working for the projects.
Oh, great. Yes. And I see Ninad's on the call too. And like you guys have been doing great community work over there. Thank you for joining us and like holding it down. As I said, it's like the middle of the night over there. So appreciate that. On the other side of the world, you guys are doing similar types of activities in the community to get everyone started with all this.
Yeah, actually we can do the gain tuning point of view and PID tuning.
Okay. What did you design this little robot in? Did you design it right here in Omniverse, or did this come from like AutoCAD and was imported?
360 we need to design first. We need to follow some certain of steps to create a joints and links, and then we have URDF converter plugin for the Fusion 360. We need to convert the URDF to the ROS to URDF format. So it will be created with a launch file script for a gazebo. If you are going to use a gazebo, it will create a gazebo launch file and with the RVS launch file, and other parameters and sacro files will be automatically created by the single click in Fusion 360 while enabling the plugin, URDF plugin.
Yes. Okay. That's great. And like you mentioned Gazebo I have used in the past with JetBot. Again, because it runs on JETSON. And last night I was looking into like, okay, if I want to do this VLA, but on the UGV and have it be all self-contained on the JETSON so that anybody can pull it and run it, I might look at that again. But really want to get on the Isaac Sim as like, this is just great. All that's on here and is like a whole other world to dig into. And if you just look at all of the work that's being done on the 3D content generation side of Gen AI and like the world building results that came out of SIGGRAPH and NERFs and all of that, it's just as incredible or more so than all of the LLM stuff that's coming. And what we're heading towards is this big merge of all of these technologies being used together, where like the 3D content generation is used to simulate the world that is training the vision action models, all running in cohesion together, and is really cool to see. And those guys on the Isaac Sim team and Omniverse like really are skilled and talented at what they do. I appreciate that a lot. And thank you for illustrating everybody how easy it is to get started with that and just hacking in those launch files. I believe the minimum spec to run Isaac Sim is a 3070 8GB card. They do have it in the cloud, and there's this Isaac Automator project that will spin it up for you in AWS, Google, or Azure. So there are options for if you don't have one of those systems. That said, hardware in the loop, the latency is such that you would probably want a local one. So like you just had it running on a laptop there, right, Gamelin? What is your development system like?
Actually, I was using RTX 4060 with my system.
Okay. Okay. Yeah. I'll have to like pick one of those up and start doing it, because the long term, like, yes, that is where this is heading, is massively scaled synthetic data generation in Isaac Sim for, like humanoid tasks and UGV navigation and like all of that. And you can play around with it on your desktop, spin up the cloud instances to like generate an endless stream of data, which is really why with that OpenVLA study, I was honing on like, if I just connect this directly to the sim and generate data perpetually instead of repeating it and overfitting it for 30 epochs or whatnot, what does the scaling look like then? Because that is what we're going to start to see, and the integration of like the mimic gen techniques into the sim, so it's more procedurally generated with the natural language prompts and everything. So there's huge teams of people that are working now to solve those like significantly complex problems for us, and we hope to just be ready to drop all that in to our systems and workflows when it becomes available. And for now, we start like characterizing the models, learning how to do the fine tuning ourselves, and understand like how it all integrates and plays together. Even though the models we have today might be basic, it might stack blocks like a 2-year-old toddler, right? But it shows like the capability of learning and is going to understand like how much data do you need, how long does it take to train it, how fast, or like what do you need on the inferencing side to do it, and proving that like if it can stack the blocks and learn that way, you can essentially teach it anything from there in the sim environment and do sim to real. So thank you for all that. Please continue like to working on that, putting those out. We can like collaborate with the group here and like what they want to see next. What are you going to work on next, Gabriel?
Yeah, we was working on Riva model to implement with this robot or the mechanism wheel robot. So
nice.
So Ninant is already start working on that. So my point of view, I need to create a roster node for that.
Awesome. Okay. I hope that you show it at the AI Summit coming up this fall. That'll be great to see and get some Gen AI stuff there. Awesome. Well, thanks again for being involved and doing all this, and look forward to continuing reading your great articles that come out. And we'll have to put some of these on JETSON AI Lab, or like an index of them. We should put like a curated thing to like follow of those rather than like rehost all of them and have you just retype them, because you do have a lot of them that comes out, like a whole tutorial series to follow. Okay, so that was very helpful discussion, guys, about like where we're heading with using ROS in this, what we need going into this slightly different data-driven paradigm with it, where it's like maybe the models are simpler, but the amount of data is extremely complex, and sim integration and everything. With the time we have remaining, Vedant from Miru, I saw, was on the call earlier. Hopefully he's still there. They have this awesome Edge AI info that they've been building up. Vedant, are you there?
Yeah, I'm here. Thanks.
Awesome. Thank you so much for sticking around. Feel free to screen share and walk us through your platform.
Yeah. Let me pull up my screen.
Oh, you guys are all there. Thank you so much for yeah. Well, I hope everything's been going well for you in your startup. And I think it's great that like much like this group, I feel like you fit in with like the ethos of us, and hope you come back and we're able to leverage this work too.
Definitely. Yeah, no, we're super happy to be here. We've been playing around with the JETSON for a while now, so it's cool to be part of the community.
I appreciate that. Yeah, and I understand it. Sometimes it's not super easy to get started with, but then again, like AI is hard, and you guys are out there trying to make this easier to scale up. So thank you.
I can quickly introduce ourselves before we share a screen. I'm Vedant, here with my co-founders Ben and Armel. We're building Miru, and we're going through the YC batch right now. So we're backed by Y Combinator. Let me share my screen, and then I can kind of show you.
And where are you guys out of? Is it?
Oh yeah, so we're based in San Francisco right now. This is
You're in it. Yeah.
In the back.
This is awesome. This is out there living the dream. You guys have like a house together. Probably sleep about 3 hours a night. It's great.
Can you guys see my screen?
Yes, and your website's very nice and clean, and
I appreciate that.
all that.
Yeah, so at Miru, what we do is we build the deployment infrastructure for robotics and IoT. So we help companies who use, for example, the JETSON device that we're focused on to deploy software over the air. You know, without Miru, as I'm sure you guys would know, it's really difficult to either SSH into the machine. It's really tedious to pull all the files down every time, and it's not scalable, right? Like once you have a lot of devices out in the field, you need a robust and reliable way to deploy software, and building that yourself just takes a lot of time. So our goal with Miru was to make that really easy for engineers everywhere. And so I guess in the purposes of this demonstration and the time we have, I won't show you how you install the Miru agent onto your device. Suffice to say, we tried to make that pretty simple for you. It's just one Debian package, one command that you have to install. And if you're using a JETSON, you're already running Ubuntu. And we just help you install Docker and Docker Compose, which is what we've architected our system based off of.
Nice.
So that's the Miru agent on the device side. But on, I guess, the cloud side, what Miru helps you do is you can push a change locally to GitHub. We help you build those containers in our server, stage them for deployment, and then help you deploy them down to your devices. So obviously, the first step is you want to be able to integrate your GitHub. So we help you add your GitHub repository. As you can see here, I have a few ones that I've already added, some demo environments. And we've kind of made this thing called a GitHub source. So basically, anytime in this case that I push to the main branch in my to-do directory, Miru will kind of track that or notice that and build that container on our server. And so giving you really fine-grained access to, you know, what changes do you want to track, what do you want to deploy, and can kind of go into that more as we go through this demo. So yeah, so with Miru, like I said, we help you deploy software, and you don't want to have to just deploy it one by one to each device, right? You want to be able to kind of batch them to fleets of device or groups of devices. So we've made a device group kind of thing here. And so what a device group does, it's a group of devices that kind of need the same software updates. And so as you can see, you can add the sources that you want to be tracked for each device. And then or for each device group, and then you can make those there. As you can see here, we have the demo environment 2 for this device group. And so every time we make a change or push a change to one of those GitHub sources, those will get built for this device group. So going into the device group here, there's kind of two main sections. One is the stage deployments, and then one is the actual devices themselves. And you can be able to track them all in kind of one dashboard. Yeah.
Something to add too about the sources and the use case. We also really wanted to make it easy for development purposes, not just for production. So with the sources, what it allows you to do is like you could have a main branch where that's actually the production code you push to, but then you can attach a development branch that you want us to track. And then when you push to the development branch, then on this page here, you can decide which devices you want to first receive the update so that you can test it locally before you then roll out to all of the devices out.
Yeah, exactly.
Okay. Yeah.
Yeah.
And can this run like jobs too, or would your containers have the run commands for those jobs embedded into the container itself?
Yeah, so right now we're using Docker Compose to containers. But yeah, you can embed them in the container yourself if you would like as well.
Yeah. No, I was just curious because I have that issue here of manage. I think I have like 10 of them that I run the JETSON containers on, which, like, true to form, I like get things about 90% of the way, and then fortunately folks like yourself are able to come and like actually do it right and be able to fully integrate it, because it is needed. And I'm sure over time you will see this vastly scaled up to fleets of IoT devices. That there's a lot to build on here for you guys. It's
definitely. And so I guess to quickly finish up, like Armel was saying, whenever you make a deployment, you don't want it to instantly go out to all your devices in the world. You maybe want to stage them, do a canary rollout, something like that. With our stage deployments here, you can actually decide, okay, which devices do I want to deploy to?
We've learned from that. Yeah. But I mean, JETSON is an interesting cross section of between like we're like the bleeding edge prototypers, but it's also used in safety critical systems, right?
Yeah.
So for sometimes it is a challenge with like the form support and whatnot for folks to understand both sides of that coin. And it already is the case, but there will come a time where this stuff is in critical infrastructure, and IoT security is paramount. And I'm sure you'll, like, we have the AB partitions and other things, one-time programmable fuses and secure boot. If you could like help people understand and use all of that, because there's a lot of enterprise industrial grade features in Jetson that are just not super well understood, because you have to be well versed in those newer Linux technologies. Make that nice web UI wrapper around them and everyone's able to use them remotely. I get one question that I want to make sure I ask you is, so these Docker images, they just keep getting bigger and bigger and bigger, right? And there's no real way, and the models too. What is, for these edge devices on LTE or lower, what do you think that's going to look like for field updates of those when it's like a 25 gig image or whatnot?
Yeah. So it's a great question. We hear this like all the time. The way the images are done, we have our own container registry. So ideally the base image is cached and you only pull like the updates that like the difference between each image. But we know that occasionally you will have to change the base image or do something drastic if you're putting to production. And so we're working on different ways to make that really easy for you and work around that. But essentially, we're using the Delta updates that are native to Docker containers to make that really, much better.
I think over time, continue to look in that, because it will be okay, I'm doing federated learning across my IoT device, but then how do you push down like gigabytes of data for it? I think, sorry, go ahead.
Yeah, and then tactically, like, networking goes in and out, especially if you have a device in the field. And so we're thinking about ways to how can we institute like fail safes or rollbacks when you're trying to pull down an update and something fails, so that you don't break your device trying to make an update. And those are the things that we build in our infrastructure that are also really important to make sure that it's reliable even when there's bad networking.
Yeah, because I even have this problem out of my cabin. I'm trying to think of, now we're actually getting to the point of using this stuff, even thinking of like the comms, right? It doesn't have good LTE out there because it's in the middle of the woods. And there are some interesting Wi-Fi solutions that they're basically like long range Wi-Fi endpoints and repeaters that it's an RF signal at that point, and you have like local Wi-Fi converters on each device, but it requires you essentially to have an antenna that's high up on your property. But I'm just like thinking about this as like, okay, somebody actually has a fleet of these and wants to do IoT and big data for their property, farm, business, whatnot. What does that actually look like to them? And there was a comment here in the chat about like, can we remotely read Flash or like not need SDK manager? And like all those things are great that hopefully you can dig into it and figure those out.
We're going to tackle, just to answer that question in the chat, we're going to tackle like remotely like updating the firmware in your OS and making that really simple and easy. We know that that's a tangle and a mess, so we're trying to figure out the best way to do it.
Yeah. Thank you. And if you haven't already connected with Chitoku, I think he is on the call here. He is our guy that had made a lot of the Jetson AI Lab, but also works with the L4T team on like those usability flows, and has always been our guy to do like the image builder tools and min disk image and those things, and is working with them right now to spec the flashing workflows for like Thor. And our holy grail for years now has been like self-flashing capability, right? Where you like don't need the Linux PC to do it. So I'll make sure to get you guys in touch, you and Chitoku, because he's like one of the most experienced on the team with like the imaging side of things, which ultimately comes to be quite important. And I hope that you grow this into like the whole edge to cloud thing. And there's a lot of runway for you guys here to expand.
Yeah. Yeah, definitely agree. And just in the interest of time, just like quickly showing the last part of kind of the platform is.
Oh, we always like run late in this meeting.
Oh,
Sorry.
okay.
Normally,
Cool.
normally we go about an hour and 15 minutes.
Okay.
So it's fine.
Yes. So so we kind of showed the stage deployments and how you can decide, okay, this deployment stage, now I actually want to pull it down, have the device pull that deployment down. Going into the device here, we can kind of see before the call, I already deployed something. So we'll be able to see, okay, what's the status of the device, of the deployment, and then also be able to see the actual containers running on our device, and just get better information about those. And as you can see, so like this deployment that I had before, you'll be able to see the commit hash and be able to just track those as well. So you can track the version changes over time, because those always get messy. And I guess the last thing I'll kind of do is I had a commit staged, so I'll just push it, and then we'll be able to see if I refresh. So we'll be able to see this deployment now preparing.
And I think something to add, like, I don't know if any of you guys might have used Vercel before, but I think something we wanted to come in and do with our product was really make the deployment experience as simple as what's been happening on the UI and front end side of things. There's been so many tools that have been built, like web development back in 2000 was completely insane. Everyone was building their own things, and we wanted to
look really nice what you've made. And even like I've had to learn. I swear I've never learned JavaScript, and I have for all this, and we'll never do a coded UI again because of that. But it's still like, I feel it looks really nice.
For sure. I appreciate that. I guess I guess Martin, did you have a question? I saw you raise your hand. Don't know. You had a question.
No, I had a question about just another topic.
Oh, okay, sorry. Okay, no worries.
What do you guys? What does your feature roadmap look like? This or like what are you working on? I hope you got some good customer interest or whatnot to propel you.
Yeah. So I guess on the company side, we're working with a few different customers right now, kind of piloting with them, and actually our first like really big production rollout is happening this week. So that's really exciting.
Okay.
Thank you. Yeah. We'll need it. On the product side, so some of the features, I think the next 1 to 2 months, the big ones are, one, helping you reflash your device remotely, kind of as we mentioned, and then being able to kind of do like configurations, so like environment variables, like globally between all your devices, and make that really easy through the UI. And the last thing is being able to actually SSH into your device through our UI, so that if you need to do any monitoring or logging, making that really easy rather than having to have like 10 different windows.
Put a little extra effort into the security on that one now, but yes, like that's great. And eventually you could even have like some LLM Copilot in here. So does this server can run on-prem on like my local cluster if I wanted it to?
Yeah, we haven't had a user ask that yet, but we built it in a very portable way so that if you do want to run it on-prem, it is 100%.
Yeah. Could you imagine, like, this is the orchestrator that controls your robot fleet or whatnot, and maybe you have some plug-in infrastructure in the future that, because down the road, this becomes like a sensor fusion, data point where it's not like you shouldn't be replicating all that edge to cloud stuff, but like tying it all together into a more cohesive dashboard of, instead of like, oh, I've got like AWS and JETSON platform services and like my LLM agent and like all this stuff, and like ROS biz and how to like present that without having to create it all yourself.
Yeah, I guess so the kind of last thing we'll say is, like, for us, like, the three things that we're really, really focused on is, one's like reliability, just making sure that you're always confident that when you deploy your software, that's going to work, and we have those fail safes and rollbacks in case things don't work. Next is security, like you mentioned. If we're going to communicate with your device remotely. It just needs to be secure. You need to be confident and to know that you can like trust this with, you know, as your infrastructure. And the last thing is that what Armel was mentioning was the developer experience, right? Like, I think that we, like roboticists, people building IoT devices, just like deserve to have like really nice tools that they really like. And I don't know. It's there's a lot in the cloud. There's a lot of like just general SaaS, but I think that people deserve better tools on.
Yeah,
for
it
robotics
has
and
been
IoT.
enlightening with like the open VLA stuff to really get into how do all these spot instances work and like all of that. And it's like pretty nice and easy actually to do. So yes, as per usual at the edge, we are like scraping by because like, yeah, the challenges that we solve are difficult constraints. And have you thought of like this notion, not to like overdo the term, but like this like app store where, because there are lots of containers and services out there for JETSON, and like, for example, like the JETSON platform services. If I could click a button in here and be like, hey, spin up my video storage server or my, you know, Gen AI Llama 3 nodes, or like last week, Gappy SDK, or like we were just talking about ROS 2 or Numerous was here. Everybody has all these different components, right? And to be able to have one thing you can just like click and deploy it all would be really nice.
Yeah, that's I think like, so like right now, right, you have to start somewhere as a startup, and you have to focus on certain things. So yeah, I think like for us, like we do see that it's kind of evolves as like
I think there would just be like a container registry, like you have a curated list of like containers that you like, and because that's by that point it doesn't make a difference to you.
And if anybody's like would actually like be interested in using that, or like we'd love to learn more about like how you might actually want to see that or like interact with it. So yeah, definitely reach out to us. I'll drop my email and the Miru URL in the chat as well.
Okay, cool. Thank you guys. Yes, and I hope that some of you that are in the group, if you have use cases like this, do reach out. The members that join this meeting and the forums are incredibly varied. Everybody from like students to startups and professors in industry, and I know there are people here that are into things like that and are hopefully able to connect with you. Okay, thank you so much for coming and presenting. In a few weeks or months, when you have another, you know, release or whatnot that you want to highlight, please feel free to come back and update us on your latest. All right, thank you guys, really appreciate it, and best of luck on your big deployment this week. Okay, so with the time that we have left, last week this big new image model came out, Flux, or maybe it was 2 weeks ago. I don't know. Azir's been cracking on it and has some fun things to show. Azir, I don't know if you wanted to take over. And we had done stable diffusion on JETSON since like that came out, and was actually been great for a lot of the marketing assets that we've done.
Yes, can you see my screen?
Yes, we can.
Yes. So okay, I'm gonna do it quickly because I know it's a bit late. So basically, yes, we managed to put Flux on plus Config UI, which I think it was new, putting Config UI on the JETSON device.
I've not seen that. Yeah, I don't know if Steve Karam's on, but I'm sure he would like that.
Yeah. I don't know, but it works very, very well, by the way. And I did some tests with doing inference on Flux with the JETSON AX Orin using the small. There is a model which is a 4-bit model. It's the NF4 model, which is called Snell, with 2 LoRa's and 4 steps. And I will show you some results now. And it takes only 23 seconds per image. And with the developer model, which is a bit bigger and more quality and 20 steps, it took like a minute and a half, kind of. So it is a very, very, very good very good platform now for Orin. So this is the first result I got. This is using the Snell model, yes, and I'm using 4 steps only. So this took 23 seconds. The first time, of course, it takes more because it needs to load the model.
That's faster than SDXL is like 30 seconds.
Yes, and you can do text. you can do text, and it's quite detailed. But we will see more now. So basically, I'm going to skip a bit the installation process. You have this in the JETSON AI Lab side. It's very, very easy. Just you need to like use PyTorch.
It's not.
We'll do the wheels are already there, so yeah.
You're not having to patch the source. So if nothing else, it's great that Comfy UI runs on this. That's awesome.
Yes. So some results. So this is just the typical, the typical boxes that NVIDIA had years ago with the text of JETSON Orin, some other results.
We have to send that to the. We gotta send it to the box designers for
we should send one of these ones, right? Yeah. And these are more advanced results. So this is using my LoRa. So what I did is I train a LoRa with some pictures of myself, and is this one in the left? That's the safe tensor model plus a Flux realism LoRa that the Flux community has released that gives a bit more of a realism to the pictures. And
that is wild. Yeah,
that is wild. Yes, and I'm gonna spot myself here 1 second. I hope you can see myself bigger now.
Yes.
Okay, so this is the JETSON right now. This is the AX Orin. It's an example I just ran. So I'm gonna show you some quick examples. These examples took like a minute and a half. So each iteration, I'm doing 28 steps. So this is maybe an overkill, but the quality is a bit better. So it's 5 seconds, 5.3 seconds per iteration. So it's taking maybe 2 minutes. And I did some fun tests with my face and different things. And this was with 20 steps. The quality wasn't so good.
Yeah.
That's why I increased it to 28. But
it's an amazing improvement over where it was.
Yeah, me with the black hair.
Yeah, it's pretty wild, honestly. It would just make you think
very wild.
Applications.
It is.
And
can I virtual avatar?
Yes, what?
Can I ask a question? Is this inside a Docker or is it just like natively?
No, it is not a Docker yet. We will build a Docker if you want. I know Dustin.
Yeah,
Dustin
drop the link to. Yeah, he just put the JETSON AI Lab page on there.
Yeah, it is on JETSON AI Lab.
It's just PyTorch is the dependency, so it was pretty.
It's bits and bytes and PyTorch and.
Yes, exactly. So if you enter here
in your JETSON container.
If you make the Docker, push it to JETSON containers, and I'll build images for everybody.
Yes. Oh wait. Okay, I think I'm.
Docker would be amazing.
Wait a second. I should turn this off. Wait a second. I should turn the video effects off because you are not seeing the screen basically now.
Oh, there we go.
Now. Yeah, there we go. So this is the page. So probably you were not seeing the results also. So I was sharing this, the workflow.
Oh, okay. Yes.
Yeah.
This is
so
amazing.
That's why you were not seeing the. So yes, these are some results with the previous model, the 20. We thought before the 20 steps, and these are the results with 28 steps, which is like really crazy. And I'm gonna show you something more. Quickly, switching to here. Yes, and something else. So the one more thing is that Flux and Config now are running on the JETSON Nano, which is quite crazy. I have been fighting with the Nano for some days because we needed to run it with PyTorch 2.4. I also tested with the latest CUDA, which is the 12.6, and it is working perfectly good. These are some examples from last night. So basically, this is probably the smallest and most power efficient Flux running device in the world. It's super cheap, and you can have Flux running on this device. And for what? You can think about use cases, but probably you want to have this kind of ads on the street. You can have a very small computer generating images. It's taking 2 minutes for this kind of images. It's like 2 minutes. And if you want more realistic images, it's going to be much more. I didn't do the test with the LoRa's and stuff, but this is for half resolution is 2 minutes and only 20 seconds more for the standard resolution. Okay,
good to know. Yeah. What is the actual memory requirements of it? Like how many billion parameters is Flux?
And I'm gonna show you. Yeah, I'm gonna show you something quickly also here.
It is like it's so good that.
I'm gonna switch to the Nano.
To be honest, you can understand people's concerns about like content generation because it's amazing. But for us in Cinderreal and virtual world generation, this is incredible, you know.
Okay, this is the Nano, but give me a second because it is oversized right now. So this is the Nano right now, and I needed to increase the swap to almost 64 gigabytes because it's taking like 31 gigabytes of swap.
I don't even understand how that's possible. It works, except that all the weights are just sitting in swap. Your poor NVMe is gonna. I don't know. I don't know.
Broke some records.
Yeah. The amount of like read-write cycles you're putting on your NVMe with this is.
Yes, I don't know how much it's gonna last the NVMe, but
it's good to show like you could do it, and hopefully somebody will do a distilled model of this or like TensorRT version. I knew they did that with Stable Diffusion and got that. There were cool videos of people doing Stable Diffusion at 100 FPS.
You will see there that the memory is increasing quite a lot. So the swap memory now is 30 gigabytes now.
You have a 260 gigabyte swap file to run.
Okay, no, that was a different test I did this morning. Okay, you don't need that.
Yeah. It's amazing.
I did that test because I wanted to see if you can generate a 2000 per 2000 pixel image in the JETSON Nano, which is not possible. But maybe in the Orin, I haven't tested. This was like to test the boundaries of this, but no, you don't need that big. So
I think it speaks to the culture of like our developer community here that we go to extreme lengths to optimize and run stuff at the edge. And sometimes it is like, okay, 8 gigabytes is for future product generations. Yes, the models today require significantly more RAM than that, but still, like, yeah, you can get an Aura Nano. The EDU discount is now back online. Let me link people to that. Actually, I meant to mention that earlier. It's part of a back to school campaign that we've been running. The discount is now $299 for Aura Nano.
And one more thing also. So this image has been generated with the Nano, by the way, and we are preparing something to show how you can train on the JETSON. And the hero here is Johnny Nunez, who is in the call. He was able to put this into. He was able to train his own face and his own LoRa on the AX Orin at a very good pace. So how much it took, Johnny? I don't know if you can tell us now, but you can do probably a tutorial next week.
For the first examples, I think that it's only 30 minutes, but the complete training in the script, that is 2000 iteration, it's around 6 hours. So
it is really good. It's an overnight training.
Yeah.
So.
Yeah. I think the overnight things are fine. And
exactly.
You said that was on AGX 64 gigabyte, right?
If you want to train this, for example, you need an A6000 GPU or that is very expensive, and with JETSON it's possible to.
And those are expensive, or those instances are to rent if you do it all the time. And like this Open VLA stuff, if I would have rented a cluster for the entire 4 weeks that I was working on this, it would have been several thousands of dollars. But since I did most of the LoRa's locally on my JETSON, I only needed those to train the final big models and solved a lot of like just pipeline issues that would have been wasted, all that cloud compute. And ultimately, it's not even just about like the monetary thing, it like the environmental impacts you want to reduce too. And these little JETSONs, so it's like a kilowatt hour per week that they run. It's very like eco-friendly to do this. It does slow you down a little bit, you know, like you said, like you try something, get your training script set up and let it run overnight, see what you got in the morning, maybe keep a couple of those going, and then when you get promising results, spin up an instance with, you know, some of the enterprise GPUs and give it a go. in my experience, those only need to run for like a couple hours and get you much better results. But overall, I think that like development paradigm where, yeah, with like this discount, anybody can get an ORIN Nano, or the price of the AGX ORIN is $15.99 if you're a student, which I get, like that's not cheap, but in comparison to like other desktop systems with a comparable performance or larger enterprise systems, is actually quite affordable, and you can start a whole AI career or startup just with like that device in the right motivated hands. And like, yes, this image generation technology is a little tangential to what we're doing with Edge, but it does all connect back, not only for like virtual avatar stuff. Like, yes, obviously Azir, it renders photorealistic pictures of you that you trained locally with the LoRa. You can use that for all types of virtual avatar AR things, where it's like I'm speaking to a person on the other side of the world, but they're like in front of me. When you couple this with like audio to face and stuff,
there are a lot of use cases possible.
Yeah,
Imagine a
but
satellite,
the
a satellite using satellite images that it has time. So there are a lot of possible use cases.
They are directly applicable. It's much like, oh, so Llama chatbot comes out and everybody's very excited. We're interested in it for Edge, but not so you can do a chatbot. It's for all of the other things that follow, like the function calling and stuff that we add on top. We have seen folks do diffusion models for image processing. There's this one project on the website that I'll link people to, the Clearwaters one. Here it is. And simultaneously, there's been more interest in the NERFs, neural radiance 3D reconstruction field at the edge for doing mapping and SLAM-like applications. There was a cool one that came up over the weekend called Fruit Nerf, which is runs in, yeah, let me find that from our chat. Here we go. I'll post that for people too. So, and it had been in the back of my mind for a while now that like, oh, these NERFs could actually be used for edge stuff. And I hope that you and Johnny go out and continue to investigate these diffusion models for edge. And it'd been on our research group webpage since the beginning, like, hey, we want to investigate diffusion models for image processing and other 3D mapping tasks, the whole sim to real component. Because like the holy grail is like the robot scans its own environment, starts simulating itself, and is able to, like, when it's asleep, learn new things from the day. I was just reading like a psychology piece last night about how in their sleep, humans like reimagine the day's events and simulate them in their head while you're in REM sleep, and that is like why you feel rested at like the in the morning. It's all of that like cleansing that goes on. I think robots might have a similar like nightly fine-tuning procedure that occurs based on what they learn, and these NERFs and other generative diffusion models can greatly aid in the synthetic data generation for that, much like we saw with Mimic Gen for OpenVLA, just like fully automated in there. So if you guys want to take this and apply it to actual edge stuff, that would be awesome. It is fun for doing like the marketing assets and stuff. Initially, our concept from the marketing campaign for this was like Llama does its own campaign for JETSON and like runs itself essentially, and you can see it. It like can kind of get towards that territory. But I think if we put some focus and effort into actually applying diffusion models for edge processing, there is enough there to go on. So hopefully you guys can, if you're interested in that, take a crack. I know both you and Johnny are interested in like the graphics side of things and feel like it's probably a good fit. If there's anybody else in the community that's working on a similar thing or is wants to team up, please feel free to reach out. But with that, we will try to wrap up for the day here. Thank you, everybody that was stuck around the whole time. We will meet again in 2 weeks on September 3rd. We will keep cranking on this. I'll put the VLH tour out in a couple days. Hopefully by then, I will also have a version of the UGV running in sim. I do want to spend a little more time in sim before getting into like the real world robots on that, before everybody has a packaged version. Azir, Johnny, hopefully in the next 2 weeks, we can scope an initial, like, I don't know, diffusion model image processing example or a nerf. See if you can get a nerf to run on JETSON, okay? And like what type of FPS that looks like. Take the NV research stuff and see if you can run some of that, just like you did here. But to everybody else, thank you so much. We will continue to keep working on all this, making good progress. And yeah, stay in touch until then. Otherwise, we'll see you guys again in 2 weeks. All right. Take care. Thank you, everybody.
Bye.
Appreciate it as always.